Thank you for joining us this morning for another version of MOBIO Breakthrough. We're really delighted with the participation in this program, and designed to take care of sharing of information across the state, and kind of when we have meritorious action or a fast moving company or a new product offering, we really try and get that information out to our members. So we can do this even more frequently if you've got storylines, if you've got information that you feel need to be shared. In this case, some of our friends in mid-Missouri and in St. Louis jointly said, you need to get the Elemental Enzymes story on there. And so sometimes the companies come to us themselves, and other times they're nominated. And we are thrilled to have Brian Thompson with us, one of the co-founders of Elemental Enzymes, to talk to us about that important story that is just really moving quickly. Also, pay attention to MOBIO Progress and the MOBIO website. You'll see that we're also doing member profiles each month. And for example, this past month, was Excite Pharma Services out of Lee Summit. Coming up next month is the Donald Danforth Plant Science Center. Really pleased to be able to feature them in our member profile. I know a lot of folks shared some personal and professional grief over the passing of Bill Danforth this past week. Someone that we all recognize is just was so critically important to getting the life science movement going in the state of Missouri, for a visionary, a man of means that also stepped up and not only put his money in, but put his heart and his inner drive and brain power towards it. We will forever be grateful for Dr. Danforth's contributions and leadership and mentorship to the entire life sciences movement. And so wanted to make sure that MOBIO gives credit where credit is due. We will miss him and don't want to bring this meeting down, but it's just really important to remember those big footsteps that have gone before us. And so for those of you that are really feeling that loss, we understand. And he was just really important to St. Louis, Washington University, BioSTL, and all of the folks in the life sciences movement. Elemental Enzymes had its starts at the University of Missouri in some degree, and the Thompsons are entrepreneurs that that leverage the Missouri Innovation Center quite strongly. We started hearing rumblings about how good this prospect was years ago, and we are real proud of the success that's that they're enjoying through a whole lot of hard work. No further ado, Dr. Thompson, the channel is yours.
Will you click on the authorize share screen button real quick?
Yes, sir. I need all the help I can get here. You're now the host, brother.
Thank you. Let me pop up the talk here. Sorry, I'm gonna start it in the middle for some reason.
Yeah, looks great.
Let's go to the beginning. All right, well, I do want to thank the MOBIO Association for allowing us to talk today. I'm very happy to see a large number of people who actually helped us in our early days here in attendance, and we wouldn't be at this point in our company's history without a lot of support from a lot of groups. And I do want to thank everybody on the call that has helped us over the years. We are, as you mentioned, a spinoff of the University of Missouri. We started in the MIC in Columbia, Missouri, and we've since expanded to 4 locations across the globe. But I really want to talk about really where we're going today, and this is just a concentrated part of our business is around enzymes and peptides in agriculture, and really highlighting one of the breakthroughs that we've been pioneering over the last few years on a very important disease for agriculture. And without that, I will continue to go through here. So really I'm going to talk about a little bit about our company itself, Elemental Enzymes, and about one particular product of ours, Vismax, which is a game changer in the citrus industry. So who is Elemental Enzymes? I mean, there's a lot behind this, but really kind of by the numbers, we are a growing leader in the enzyme and peptide technology. And this is a very fast growing aspect of agriculture. Let me drop this real quick. By people, we have 38 full-time equivalents. We have over 10 PhDs. We have 10 commercial products on the market with 9 pipeline products to be launched in the next 2 years. And we are a fairly prolific R&D company. We have 143 patent applications and 27 issued patents. And so we are generating a lot of knowledge, and we do work with a lot of the major agricultural companies out there. And we have a list of partnerships, which I did not put in here, but we do have products in a lot of different avenues within agriculture. And I mentioned we have the 4 locations, including we continue to have a location in Columbia, Missouri, a location in St. Louis, one in Jacksonville, Florida, and one in Melbourne, Australia. So really a little bit more about our company. What we really focus on is innovative cross-disciplinary solutions to complex problems impacting commercial agriculture. We really highlight specifically enzymes, as you probably could guess from our name, peptides, and natural solutions or natural chemistries to both improve health, plant health, performance, and yield. We do this on a variety of crops and a variety of regions and a lot of different application methods, but this kind of captures it in a short, concise fashion. Our products create very specific organic responses that are natural, safer, and more sustainable. The base of the majority of our products are either enzymes or peptides. These are made up of amino acids strung together. When you put amino acids in very particular structures, they can catalyze chemical reactions, or they can bind to plant receptors. And these have very important and potent effects on plants. And they also break back down into amino acids and have a very good safety profile in that amino acids are one of the safest things you can have being released back from chemical type products. So have a much better safety profile than your typical traditional chemistry. One second. I have the allow people in the room over top of my slides, so it makes it hard to see. All right. One of the major things that we do is we develop peptide systems. These are small, 10 to 20 amino acid proteins that interact with the plant and cause the plant to respond to either abiotic stress, diseases, or we try to trigger the plant to reprogram itself to be more resilient to different challenges. So these lead to upregulation of genes and pathways that increase plant immunity. And I'm going to talk about one of these in particular here at the end of this slide around citrus. We also are an enzyme company. We have 600 different enzymes in our discovery library that we screen and are using on plants. And like I said, this is nature's way of producing chemical reactions. We're really just trying to give more of those reactions to be more efficiently. Some of these different enzymes can be put together to regulate microbial community, stimulate nutrient conversion, immune modulation, or as insecticidal toxins to protect the plant from insect pests. We do develop a lot of different enzymes for a lot of different categories. One of the main things I want to highlight today is around what enzymes do. Enzymes, we use them primarily to prime the soil. This is basically to get soil more active and more alive. So when that plant germinates and starts to grow into that soil, there's more nutrients available for that plant. And that gets that plant off to a better start to the beginning of the season. So the key concept here is really prior to the seed even germinating in a soil, the enzymes are released to act on substrates or targets within the soil. And that enzyme working as kind of a little machine in soil will lead to more nutrients being available for that plant. This really does give you a large yield or benefit to that grower by getting those plants out of the ground as fast as possible and in the best state possible. One of the things that we really work on, although I'm going to oversimplify it here in this talk, plant root systems are very complex networks, and there's a lot of distinct activities happening in different areas. And here's just a chart that I'm not going to go through in detail, but showing all the different areas of the plant and all the different things that are going on. And you can basically poke different buttons on a plant by putting enzymes that interact with these different targets. And that's a lot of what we do is really figure out how we can interact between the microbes in the soil and the plant using enzymes as a messenger. To deliver or change the dynamics of a plant's growth. So a lot of people are not familiar with enzymes and their use in plant agriculture. A lot of people know of enzymes from their use in laundry detergents or in animal feed. But really enzymes that apply to soil do something very similar to an animal feed in that they allow more nutrients to be available. So people always ask, where do enzymes actually come from in soil? And the answer is there's a lot of enzymes in soil. The majority of those enzymes are from bacteria or fungi that naturally colonize plant roots. And we're able to kind of amplify that response by adding additional enzymes into that plant system to really help them. The plants also do create some of their own enzymes, mainly to help themselves and acquire certain nutrients. But that's where the natural enzymes, we're adding a lot more of those enzymes around the roots to really kind of accelerate this process. One of the things that's interesting to look at, where is the enzyme activity in a root structure? You look at the charts on the right, you can see the fine lines of color. That's showing you where the enzyme activity in soil. And really, the enzyme activity in soil is right on the root structures. The plants make it, and the microbes like to live right on the root system. And so you can see the enzyme activity is pretty concentrated into very defined parts. There's a lot of that soil that does not have a high degree of enzyme activity outside of where the roots are itself. Here's just an example of what can happen if you add an enzyme into a soil. This is one of the enzymes that we work on. You can see on the stamp on the left, the fine light blue lines here are actually where the enzyme activity is in soil naturally. And you can see, again, only a very small percent of the total soil structure is being exposed to enzyme activity. By adding our product on top of this plant, you can see the graph on the right, and you see this diffuse stating where the enzymes are really spread into a much wider area. And this broader area of effect of an enzyme really can add additional benefit to those roots by releasing nutrients that can travel to the roots, as well as priming the area where the roots are going to grow into. And so we're really spreading the amount of soil that's being exposed to enzymes to give a better growing environment for those plants.
Brian, take 1 second, please. I need to admit some folks that were waiting.
Sure.
And I'm going to now hand it back to you, sir. Thank you for letting me jump in.
Oh, no problem. So this is looking at another enzyme, manganase, and how it works around plants. You can see just kind of where the enzyme activity is in the picture on the right. You can see the diffuse cloud-like structure around the roots. That is where the enzyme activity is found in that soil. So you can see spreading that enzyme activity beyond the roots to the area around the roots, where the roots are going to be growing into them. Really helps the plant. So again, why are enzyme proteins and peptides exciting? There's an endless possibility of actives. Nature has a huge toolkit of proteins and peptides available that they make in the environment that can be, scaled and put back into soil to kind of amplify those responses. They have a very safe profile. They're very effective. And really the two main things that are necessary to bring enzymes in agriculture is selecting the right type of enzymes to get the effect and stabilizing those enzymes to allow them to survive in soil for the longest period of time. If you do those two things, you can have an effect that's similar to traditional chemistries. And so that's a pretty high bar, because those chemical products have been developed for a large number of years to really be effective. I think nature's toolkit can be just as effective, but you just have to properly pick the right enzymes and stabilize them. They're much more sustainable and greener than many of the other alternatives used in systems. They're able to work with fertilizers, which are pretty harsh environments for a lot of products to work in, and they have a very high win rate. That means that the chances of a grower having a positive response to your product is very high. And so these really highlight why we got into the space and why our company has grown so fast, is because of the promise of these proteins and peptides. The one particular target that we want to talk about today, and this is kind of related to the enzymes, but this is one of the peptides we've been working on it. We were a couple of years ago in 2016, we decided to try to address one of the major diseases in agriculture today, which is citrus greening. This is a devastating disease of the Florida citrus industry. If you've driven around Florida, around Orlando, into the orange country, you've probably noticed this, but a lot of people in the Midwest are not as exposed to this particular disease. But if you look at the picture on the top right, this is a grove in Florida prior to being infected with HLB, which is the short name for citrus greening. And you can see the typical item what people think about for an orange grove, which is a lush green tree. Lots of oranges would be on there if it's the right time of year. But after that disease has been in those trees for a couple of years, you can see the picture on the bottom right. This is what Florida's groves look like today. You know, you see all the dead branches. It's a lot of dieback. It's not a pretty disease. It really is a very continual decline of tree health, to the point where the growers have to bulldoze these trees and start over. And the trees, instead of living for about 50 years, are really only living around 10 to 12 years. So the growers are constantly having to replant because this disease eats away at their trees until the point where they're not productive anymore. This disease is newer to the US. It spread into Florida in 2005. It spread to all of the Florida citrus regions. It is also in many regions of California and threatens the California citrus industry. Although it hasn't truly taken hold, it's kind of everywhere around them. So I believe it's just a matter of time before California gets the same kind of impact. Just in Florida, it's $4.7 billion lost of productivity. There's 30,000 jobs that have been lost in Florida because of this disease, and a 70% reduction in orange production capability in Florida. So, you know, you may have seen it in the supermarkets and seen the price, but you know, the impact is pretty dire. And there's no known true solution or cure to citrus greening today. The disease is spread from tree to tree by a small insect called a psyllid. You can see a picture of it on the bottom left. That insect sucks the bacteria out of an infected tree, flies to another tree, and injects it, similar to like a tick-borne disease or a mosquito-borne disease. It spreads it from tree to tree, and it's a pretty prolific insect that's very hard to control. And the strategies to kill the insect have not worked to prevent spread of the disease. There's a picture there of the bacteria living inside the phloem, which is kind of like the veins and arteries of a tree. And the bacteria grow at large numbers and kind of clog the arteries, or the equivalent of that, in a tree, and cause the kind of decline that you see in the picture in the bottom right. So it's, again, a pretty devastating disease, and it's a global disease that's hit most of the citrus regions in the world. It's really showing kind of what we've done to go after this disease. We started in 2016. We've tried 49 different trials across 5 years. We've tested 73 different treatments, over 4,000 trees, and we've gone after this disease in a big way. We've tested a wide variety of different oranges, grapefruits, tangerines, a wide variety of the area of Florida, and really out of all this research, we found a really good target that has a pronounced effect on citrus greening, and that's the one I'm going to talk to you about today. So I won't talk about the other 72, but this one's been pretty impactful. So really, the breakthrough was, you know, seeing the effect of one of our particular products that we tested on. This is a peptide called Vismax. Increases the yield of citrus greening or HLB infected citrus trees. Can be delivered 2 different ways. You can do it as a foliar spray or spraying it on the tree, or injecting it into the tree itself. And what we see up to a 96% reduction in the bacterial in those trees. And so that's a pretty drastic reduction. We're really telling the tree to defend itself, and the tree is actually, even in that sick state, able to fully defend itself and knock down the bacterial levels to a very high degree. So if you hit the tree in the right way, that tree can still defend itself even if it looks fairly sickly. We have 39% more flush. The trees are happier. They make a lot more flush, which is kind of new growth. And we get 20% more fresh fruit and up to 52% in various trials. We're seeing a very pronounced effect on yield increases in these trees. This is a graph on the left, really looking at bacterial infection. If you look at the gray line, this is the natural level of bacteria in those trees. You can see it's very high. The yellow and green are treated with our Vismax product. You can see the bacterial numbers crashed and stayed low in these trials. So we're having an effect that's similar to what an antibiotic could do, but we're not an antibiotic, and we're acting entirely through telling the tree that it's infected. So think of it as kind of like a vaccine type approach to orange trees. If you look on the right, this is with a different application method, but you can still see the same effect. With two different rates, we had a 93 and a 96% reduction in the bacterial levels within that tree. So again, if you tell the tree to defend itself in the right way, they can knock down the infection level drastically. This is a comparison between our peptide and Oxytet. A lot of what the growers in Florida have had to do is resort to spraying antibiotics over the trees. It's not a very effective, but it does seem to have some promise. If you look at the comparison of Vismax versus Oxytet head-to-head, we get a 25% increase in fresh fruit by applying our method versus the antibiotic will get about 99%. And so you can see it's a much more effective way to tell a tree to defend itself than it is to deliver an antibiotic to those trees. If you look at the 2-year studies on the right from the CRDF on using antibiotics, you can see it really doesn't help in the long run. There really is no benefit to those growers in using the Oxytet in getting their trees to recover. You can see it's actually a negative impact. Whereas if you look at our 2019 data, consistently across the board, we have that 19% increase in yield in these trials. So really, we're finding a non-antibiotic solution that is more effective than using an antibiotic with a much better safety profile and no residues left over in the fruit. Here's just an example of what one of the trials looks like. You can see the tree on the left. The average yield is about 2 bins or just under 2 bins. You can see on the right, the same trees, same field, treated with our product. They're greener and they have a lot more oranges coming off of those trees. You can also see the size of the fruit is increased. If you look at the bags in the bottom left, each of these bags has 36 fruit. And you can see that the bag with the Vismax treat has much better fruit. More what people are used to thinking about Florida citrus being really tasteful, large fruit. You can see we can overcome some of the negative aspects of the disease with the smaller fruit and a little bit less sugar in them. So we can offset the two major parts of the consumer sees on fruit. Here's just showing a number of different types of citrus. The first one's grapefruit. You can see the blue line, we have an 18% increase in yield over the gray, which is the controls. Tango, which is like a tangerine. You can see we have a 38% increase in yield versus the controls. And then we have navel oranges, which kind of your classical orange fresh fruit. You can see we had a 6% increase across these trials. And across all these citrus varieties, we increased the yield of citrus by 21%, as well as the bacterial counts going down. And one of the other interesting things is looking at kind of the consumer side is one of the problems with citrus greening is you get these deformed fruit. You can see a picture, I have one circled here where the actual middle of the fruit is kind of curved out because the fruit isn't grown symmetrically. The fruit treated with Vismax are very symmetrical, and we alleviate one of the concerns from the consumer in that we get rid of this asymmetry and bitter taste that comes along with the citrus greening. So really that's what we wanted to announce today is we've had a pronounced effect on the citrus industry. We hope to bring this product to market in the very near future to really take on this disease. It's been a devastating disease for Florida and the rest of the world. I think we have a very powerful and viable product that has no residue and can replace antibiotics in that market. And really just looking at, I talked specifically on citrus today, where we perform better than the #1 product on HLB. But we're also more effective than leading fungicides on almond diseases, kiwi diseases. This is a broad effect that people can go after using nature to really attack major diseases rather than using antibiotics or classical type chemistries. And with that, I'd like to kick it back to Kelly. And if anybody has any questions about us, our product specifically, or about our company, again, I do want to highlight that there's been a lot of people on this call who really helped us get to this point. And we wouldn't be here without all of that assistance. So I'd like to at least say thank you to the group for all that they've done to help us.
Brian, is It seems that a lot of the application is towards tree-based plants, and you're injecting, I guess, in the trunks to stimulate the receptors down there in the root system.
Mhm.
Will you be able to go into other plants besides tree-based?
We do, and we have trials in Brazil and like Asian soybean rust, which is one of the other big diseases, and we work as effectively as chemical fungicides. So we've had there's a lot of row crop data here. I focused on the permanent crops because they have a lot of really bad disease issues, and that they can't get away from their disease. It's there year after year because those trees are permanent. So I highlighted these, but there's a lot of work we're doing on row crops. Being a Midwest company, we do a lot of work on corn and soy and wheat. And major diseases there.
But the apple tree people and the peach tree people are going to hear about the success and come knocking on your door also.
Yeah, we have data on apples. We are working on all those fruit and have really good response. This is a very small sampling of the number of crops that we've gone after. But yeah, this will be a very broad tree and row crop product.
Is there any questions across our field of participants? Do I need to be doing anything to unmute everybody?
Well, I'll start. This is Quentin.
Hi, Quentin. Thank you.
You bet. So good to see you guys again, Brian, Katie. I miss you here in the building. From an economic development perspective, I know you mentioned you had something like, what, 38 FTE?
Mm-hmm.
Like, how many people is that? I mean, what's your head count?
That's 30. It's 38. We do have our seasonal. Sorry, Brian, for jumping in.
Go for it, Katie. You're the expert.
We do have quite a few more seasonal help and on the field side and also on the manufacturing side at this time. But that is our current full-time equivalent. It might be 39. I'm thinking that we probably didn't get this last person that was hired this month incorporated back into that list. But
So those part-time helpers, is that in the ballpark of 10, 15, 20, 30? I mean,
yeah, so it varies a lot throughout the year. So the springtime, probably 5 or 6. Over the summer, at least 3 to 5 full-time in the laboratory, and then we have several part-timers throughout the year in the laboratory. Yeah, and then we'll hire some for harvest and citrus in the wintertime, and then also some for manufacturing as well. Those are 2 to 3 months.
of that 38, 40 or so full-time, what's the growth been just this last year, like the last 12 months? I mean, we brought on 10 new people, 5 new people.
It's probably about 10. It's sometimes it's, we have a couple that have rotated or replaced, but a lot of those are fairly new headcount.
Right, that's fantastic. And I need to place my order for cherry tree enzymes and peptides, if you would. I'm building my orchard and I need it for cherries, so thank you.
Yeah, the receptor for Vismax is fairly conserved across trees, but I'm not for sure if we've tested cherry trees, but I have a cherry tree in my yard now, so.
Well, I have some you can test. Thanks a lot.
I think one of the questions we get was kind of where we're located. In St. Louis, we're located kind of north of the Danforth Plant Science Center in this kind of plant corridor, stone's throw north of the plant corridor. But we have our headquarters here in St. Louis around just north of the Bayer campus here. As well as we still have our field team is run out of our Columbia, Missouri site, which is still located in the MIC. And they run a lot of our cropping systems out of there, including a lot of the almond work is done out of Columbia.
Okay.
Just to add on that, you guys all know Joy. She ran that office there in Columbia for quite a while. She's the one heading up the Jacksonville
Well, Brian and Katie, we've been working with Stacy quite a bit in preparation for this call, but we know that there's several Elemental Enzyme employees that are also participating in the call. Is it okay if they introduce themselves and let us know what function they're serving with the company?
Sure. Put Stacy on the spot if she's available.
I am here. So I'll start off. My name is Stacey Schumer. I'm a product manager at Elemental Enzymes. I've been with the company for around 6 years. So I've been able to see them go from the Zoo Business Incubator and the transition to St. Louis.
Thank you, Stacy.
And I can hand it off to Katie. Do you want to introduce yourself?
Sure. I'm Katie Thompson. I'm a co-founder of Elemental Enzymes. I am the Chief Operating Officer. So I've held a lot of roles as we've grown. One of the great things is to be able to see a position grow enough to be a full-time position and be able to hand that off to someone who's really an expert and can take it and run with it. But right now I really focus on strategy development and how we're gonna go through this next period of growth.
And we have Marshall Blank on the call as well. I'm going through the list, so just if you're an EE employee, get ready, I'm gonna call on you.
Hi, I'm Marshall. I'm a product development scientist at Elemental Enzymes, mostly working with the enzyme products at this point, but my job is to take things that have been proven in our R&D division and figure out how to manufacture them, deliver them to customers.
All right, Steve Morgan.
Hello, I'm Steve Morgan. Am I on here?
We can hear you.
I see you.
Okay.
If you
All
click
right,
on-
good deal. I'm strategic account manager. I'm based out of Atlanta and joined 90 days ago or so. Very excited about the future with the company and just can't wait to get started. Work with a great bunch of folks. Thanks.
And we have Jay on the call, if he's at his desk.
And he's still on mute. There he
Okay.
is.
Yeah. I just needed to unmute. Hi, I'm Jay Bummel. I have been working with Elemental Enzymes for about a year and a half and oversee our financial operations and serve as CFO.
And the last person who is our most recent hire, Claudia, if you can give a brief introduction.
Hi, my name is Claudia Di Maio. I just joined Elemental Enzymes. Oh, can you hear me?
Mm-hmm.
Okay. I just joined Elemental Enzymes like two and a half weeks ago. So I am supply chain specialist and still learning stuff, but I think it's a fantastic company to work for. And I'm super excited seeing all these results that Brian was talking about. So I'm super excited for the future of the company. Thank you.
And that is all the EE team members that are on the call.
Thank you, Stacy. Steve Morgan, you're going to have to get introduced to Maria Thacker down there at Georgia Bio, and she's been a friend for a very long time and is on the call with us today. So I know you guys will get connected up.
Oh, great. That's awesome.
Yeah, Kelly, I know we focused again on trees a little bit in this talk, but I think the impact that our company has is we're a very unique company in that we are very R&D heavy and we develop a lot of products that have other people's names on them in the market. So we probably don't get the recognition for the products that we have, but just looking at the row crop market in the US, we're on 7.7 million acres of corn this year. So we do have a very broad impact, but you don't hear our names flashed around because we're a lot of times kind of the secret sauce behind a lot of products.
Thank you for mentioning that. 7.7 million acres in corn is quite significant, and we're having everywhere there wasn't a Derico, we're having an above average yield, and farmers are doing pretty darn well. So.
Mm-hmm.
thank you for helping de-risk and improve yields. Have any other questions from our participants this morning? We're coming up right on 10:40, our target time, and we thank everyone for participating. Any last call? Well, great. Thank you, Elemental Enzymes, for telling your story. This program was recorded. People can go back and reference it. If you joined 10 minutes late or 15 minutes late, reach out to myself or Lisa or Michelle, your MOBIO team. You can always reach us at our first name, michelle@mobio.org. Follow that and you'll get right to us. And we hope everyone has a productive finish to their week and stays safe out there.
Thank you for having us. It was really great to see everyone's faces who we've, quite a few of you who we worked with over the years, and it's been a little bit. So thank you very much.
Well, the Thompsons are considered heroes for doing exactly what the life sciences movement has asked. Start with great research, be homegrown, move it, and not just leave the research on the shelf, but turn it into something that's productive for society. And this citrus problem, you've been down to Florida, it's a big deal. And you guys are definitely helping us all keep our vitamin C coming.
Thanks, Kelly. And if anybody has any other additional questions, feel free to reach out to us directly, so we're happy to answer them off the call as well. So.
Sounds great. Thank you, everybody.
All right. Thanks, everyone.
Thank you.
Thanks. Great work.